Yeah, so let's start with a quick quiz. How many of you people run static analysis tools on upstream projects? Something like Coverity. Okay. How many of you run them on downstream changes? On package updates, yeah. Okay. And how many of you have fully automated the process? Yeah, the real people are raising hands. Yeah, okay. So let's set. So what are we going to talk about? So I'm going to talk about OpenScanHub. Then Franta will talk about Packit. We'll talk about how does the integration work, and then some of the ideas CentOS stream and its derivatives may take away. And we'll take questions at the end. My name is Siteshwar. I'm a package maintainer in the RHEL group at Red Hat, and I'm one of the contributors to the OpenScanHub project.
Hello, I'm František. I'm a product owner of the Packit team in Red Hat, and I'm involved in various automation efforts around Fedora, CentOS Stream. And thanks everyone for being brave and finishing the end with us. So we'll try to be quick.
Okay. So what is static analysis? So static analysis is the analysis of computer programs performed without executing them. So you have a tool, you have a source code, you give the tool to the source code, you give the source code to the tool, and the tool will tell you whether there are any bugs in the code without executing the code. And some of you may be using some of the tools already, like Cppcheck, ShellCheck, or maybe the most famous Coverity. So what is the problem we are trying to solve? So the problem lies in fragmentation. And the problem with these tools is that these tools are developed independently of each other. They have different target audience. For example, ShellCheck is towards Bash or like any shell, and there are different communities or people behind these tools. So let's talk about the service idea here. So what if we can build a service that can run some of these analyzers on the code base, collect all the reports at a single place and make it easy to analyze them? And that is OpenScanHub. So what is OpenScanHub? OpenScanHub is static analysis as a service. It is open source, so it's licensed as GPL v3. It became open source in 2023 in June. And it's not limited to any specific programming language. It can scan any type of code. It's fully automated for RPM packages. And by fully automated, I mean you have the SRPM, you give SRPM to the service, and the service knows how to build the SRPM. You don't need to specify the build rule. And one of the key features of OpenScanHub is the ability to do differential scans. So what is a differential scan? Imagine you have a package, and there's an update on the package. Let's say there's an old version of the package and there's a new update. And you only want to find the defects or bugs that may be introduced on newer version. So you can sort of perform a differential scan, and a result will only contain the bugs that may be there in the newer version. It will skip all the defects that may be there in the older version. And it's extensible. For example, we support Cppcheck, ShellCheck, but if you have an analyzer that we don't support already, you can write a plugin for it. And it can collect all reports at a single place, so it's a hub. And there's a famous acronym for this service. The famous acronym is SAST. But it can also find something that may not be a security issue, anything that can be coded through static analysis. So how does it work? So it's deployed publicly on Fedora infrastructure. The user requests for a scan. The service runs various analyzers on the code base and collect the results at a single place and give the results back to the user. And that's how it looks. That's the web UI, that's the home page of the service. You can access this service by going to openscanhub.fedoraproject.org. It's free for everybody. And the simplest way to use it is through the scan submission form. And you need a Fedora account to submit a scan. So once you log in, you can go to this URL at the bottom of the slide, and you specify the NVR. And the NVR, the source RPM for this NVR will be pulled in either from the Fedora Koji or from Stream Koji. And because what we do with the SRPM is that we rebuild the SRPM, and we rebuild the SRPM with static analysis tools like Cppcheck or like GCC analyzer or Clang analyzer. So the terminology we have here is mock build. So mock build means perform a full scan of the package, and mock profile specifies basically the build route. And in this case, we have specified EPEL9 here because some of the static analysis tools are not there in CentOS stream. You need EPEL for that. And if the scan is successful, you will get a report that will look something like this in HTML format. But we also support other formats, most importantly, serif. And if your task is submitted successfully, it will show up on the task list page. And as you can see, under the owner section, you can see Packit is one of the biggest users of OpenScanHub. Like all these scans are submitted automatically through the Packit service. And Franta will talk more about Packit now.
Okay, so let's take a look what Packit actually is. So the goal of our project is to get upstream, meaning like the developers, closer to the downstream distributions. And we have like two ways how we are trying to do that. One is providing upstream CI, and one is like helping maintainers, so getting the release back to the down the stream to the distribution. By upstream CI, we mean like providing downstream feedback like the RPM builds, running tests on top of those, image builds and others, back to the pull requests and commits in upstream. With downstream automation, we are trying to get the release coming from like the Git forges for Fedora, EPEL, CentOS, and also like the CBS. Regarding that, there are a couple of other things that you can learn about these other use cases. So if you are interested in like SIG infrastructure, you can join me tomorrow before lunch. And if you want to parallelize and do something useful and eat the lunch in one time, so you can take a look how you can automate EPEL releasing with Packit. So this will be tomorrow. And also we are integrating Packit with OBS, which allows much more that we haven't been able to do. So we have a talk on Sunday on a distribution. So that's a joint talk and joint work with Dan Chermak from SUSE. But back to the upstream use cases. So you might see quite a bunch of familiar logos here, and this actually shows how Packit works. We are taking existing, usually single-purpose services and building on top of those like a user-centric workflows and provide a GitForge UI for that. And one of such service is newly OpenScanHub. So how it works is we are starting on a GitForge, and GitForge sends us information about like some kind of event to the Packit. Packit then triggers a scan in OpenScanHub. OpenScanHub publishes the results in Fedora messaging service. We are listening on that, meaning Packit gets the information about the result and provide it to the user. Sounds simple. So looking at GitHub page, so you get the new result on the pull request status as you are used to with other services. And on the check result page, like the detail page that is available on GitHub, you have like more details. You can either get directly to the OpenScanHub page, or you can get to the Packit dashboard. So looking at the Packit dashboard, you can have a detailed view on the right top corner, where you can see like some details and also get to the OpenScanHub. And one thing that you might spot is that there is a copper build thing there, and you might be wondering why we need a copper build there. It's there for a reason, because to not waste resources, because the scans static analysis is quite extensive job to do. So we are like trying to save some resources by running the copper build beforehand. So once we know that the package can be actually built, it makes sense to run the analysis So that's the first thing you might spot. And the second thing is the new findings. And that's the killer feature Situ already mentioned. Because you might been thinking like, yeah, all of this is nice, but I've been there. I've already tried to establish this new CI system to my code base with 1,000 of errors that I can't possibly fix, and I just got rid of that after a while. That's why we are using the differential scans, so you can get just the new findings that are easier to find, fix when they are introduced, and that can be like introduced into existing code base. So let's take a look how the differential scan actually works. I hope it's like clear from the name, but during the development you can take like 2 versions and scan both of them. One produces like this bug number 1 and 2, and the second version produces like these 4 bugs. And as a differential scan, so you like show just the new findings, just the bug number 3 and 4. So in the Packit's code, Packit's use case, we are scanning the pull request and like the pull request head commit, and also the commit on the main branch, like the branch that we are trying to merge the pull request into. So there are 2 scans going on, and we are providing the diff of these. But if you really need, since there are still these 2 scans going on, you can still get the full scan results if you really need. But usually you will just see the new findings, so you can fix them right away and don't need to introduce the new findings into the code base. From the Packit's configuration point of view, in Packit we are defining like stuff what you want from Packit in form of so-called jobs. In this case, we are requiring like copper build jobs. If you have copper build defined for pull request and copper build defined for commits on the main branch, we'll run the scans for you out of the box. You don't need to know much about like this setup, as I don't know much about static analysis, so it's really handy to use. And you will get the new findings as similar as Situ mentioned already. If you want to play with that locally before or like in the same time when using service, there is also a command line, so you can play with that also locally using your own FAS account, Fedora account, to integrate with OpenScanHub instead of the Packit service that tackles the like authentication for you. So if you are interested how this will continue moving on, if we will invest in that, you can actually influence that. In Packit, we are heavily influenced by the demand of the users. So if you want us to continue working on that, have some like new use cases, let us know. If we know that there are plenty of people interested in this, we will spend the time on that. If there is no one interested, we will probably leave it like this. So it's a general thing in our project. So let us know what you think. We have this GitHub discussion thread specifically for this use case. You can maybe put a comment here. Hey, that's a nice thing, I'll play with that, or we are missing this or that. Now let's zoom out a bit and let's take a look at the stream of code coming from the upstream, from where the developers are, down the stream through Fedora and other distributions down there. So that's the current/past state where all the RHEL packages are being statically checked. So that's the current space, and we are missing all rest. with this effort, by open sourcing the OpenScanHub and also having this integration with Packit, we are going left, so-called shift lefting to the upstream. So the problems can be fixed when they are introduced into real projects, when the development happens. So with this, you can check the upstream code, which is like easier, quicker, less expensive to fix, comparing with the RHEL when the life cycle is like longer. So all this shift lefting is like make shorter loop. Now there are maybe plenty of other places where this can be introduced. I'll start with Fedora. Packit team suggested that it can also take care of in a form of Fedora change proposal to take care of the dist-git CI. So this might be then an extra step that if Packit can do that, we can also introduce the OpenScanHub integration to Fedora dist-git pull requests. For the rest, I'll let Situ describe them.
Okay, so when we're doing the integration with Packit, the idea was to shift left, be closer to upstream. But when we talk about Fedora and CentOS stream, the idea is quite the opposite. Like you have to shift right, be closer to distributions. So basically, every time you make a change to Fedora, every time there's a pull request to dist-git to Fedora or CentOS stream, we should be running differential scans on that. And yeah, the scan should be added to the pipeline. So right now, when we run the scans, we were running them internally. Before the package was released to RHEL, we were doing differential scans there. But ideally, we should be running them publicly. Every time there's a pull request open on CentOS dist-git, we should be running differential scans on that, and results should be visible to everybody. So the next question is how? And the first step is to submit the scan. And to submit the scan, OSS CLI this is the command to submit a scan. And OSS CLI is the command line tool for OpenScanHub. And this is the command to submit a differential scan. So use version rebuild means perform a differential scan. And config specifies the build route. So it's CentOS stream plus APL9 because we need APL9 for static analysis tools. And one way to do is through the SRPM. So you have the SRPM, in this case, this is the target SRPM or the newer version of the package, and you specify the base SRPM, the old version of the package. So that's how you do it for SRPMs. Other way is through just specifying the NVRs. So instead of specifying the SRPMs, you just specify the NVR of the package. And the NVR will be pulled from either Fedora Koji or CentOS stream Koji. And if the scan is submitted successfully, you will get a task ID. And once the task starts running, the status changes will be reflected on, will be published on the Fedora message bus. And the topic to listen to is underlined in the second step. And you should be reflecting the status in the CI. If the scan finishes successfully, you will get a link to the results. And you can find more details on the Fedora wiki page. There's a page for OpenScanHub there. All the details are there. And so this is the last slide. I'll end you with some references. So there have been several talks about OpenScanHub. The first one is a talk from DevConf last year, 2024. And it's around a 30-minute talk if you're interested in just OpenScanHub, a longer version of like the history or the ideas we had last year. Some of them we implemented, some of them we are yet to implement. So you can watch the talk from last year. It's on YouTube. Second talk was done at GNU Tools Cold Run, and it was a brief introduction to OpenScanHub. It mostly talks about how you can use it. And the third one is a talk, MUNI, it's from Masaryk University. And it was done before the project became, like the service part of the project became open source. But the underneath tools like CSMOC were already open source. So it's a talk from Kamil Dudka, who has been working on this project for more than a decade now. So he's the lead. So if you are interested in the core ideas or some of the core details, you can watch this talk. And there have been several blogs about it. First one is when we made the project open source in June 2023, it was an announcement of open sourcing the project. Second one talks about the integration with Packit. And third one is the announcement from the Packit team about OpenScanHub integration. And that's the homepage of the project. You can find more details there. And that's all. Thank you. Are there any questions?
Cool system, and thanks for the talk. Yeah, so just curious about this diff that's going on. Seems like, as you described, you have to find an association between bugs in the prior version and in the newer version, right? Despite the fact the source code is changing.
Yeah.
Are there any tricks there? Is that a trivial process?
So you basically rebuild the packages. So you first do the rebuild of the old package, and then you do a rebuild of the new package, and then you compare the output of the.
Yeah. So these are always like independent and identifiable. Like when your source code changes, you never get any tricks, any missed bugs or extraneous bugs.
I mean, what do you mean by missed bugs? Like, it's just basically a difference. It's a difference of the output of mock. Basically, what we have done is that we have written a wrapper over mock. So it's called CS mock. So that's the core tool we use. So what CS mock does is that it enables the static analyzers and just the rebuild, and we capture the output of CS mock, basically mock with static analysis, and we compare sort of a diff, and there's the name of the tool that performs the diff is called CS diff. So basically, you get the text, and that's differential scan. So
Thank you.
I have two questions. One of them is continuation of the Tommy's topic. So if you do the rebuild of the old package, against what build root you're rebuilding it?
From the one, okay, can I go back?
Is that the same build root that the new package will be rebuilt with?
You can specify, like, either you can specify one build root. So either you can use one build root and both the packages will be built with that build root. Or for the old package, you can specify the old build root, and then it will build against that build root.
Yeah,
but
because otherwise you're not really building the right thing, which is especially important if you are having old packages that cannot be rebuilt in the new environment. Take the Fedora mass rebuild recently with new GCC, where a lot of old packages could not be built simply because of the C23 changes there, right? So you have to keep the information about the build environment that was used in the previous build for this information. And the second question, this was a comment, not more like not a question, but this now a question. So how hard is to add other static checkers for other languages?
So going back to my answer, so mock does the build. We have the tool, it's called CS mock, which is a wrapper over mock, which does the rebuild. So we have plugins for that. For example, for ShellCheck, we have the CS mock ShellCheck plugin. For Cppcheck, we have CS mock Cppcheck plugin. So if you have, you just need to write a plugin for CS mock to add the new analyzer.
Mm-hmm. So, for example, all this stuff with Python and JavaScript and Java and so on, can it be plugged into the same infrastructure?
Yeah, you just need to write the CS mock plugin. I think we probably even have some plugins for, I think, Python. I forgot the name. Yeah, also for Sneak and others. Yeah.
My question is mostly, I don't want to have this on my side. If I'm delegating this to OpenScanHub, and I just want to choose the options I run against my project, maybe actually let it detect those features based on what libraries or what languages I'm using in my code. Because in reality, in any semi-complex or complex code, you will have a mixture of languages.
Yes.
And it would be good to test both C and Python and maybe Rust on top of that, and so on. So all of these things need to be in the same, ideally in the same flow, rather than us introducing like tens of dozens of scanners through the GitForge facilities.
Yeah, definitely makes sense. There are a couple of things, like one is like supporting those, so that should be done as a plugin. We will probably want to maybe get help in that space. Then there is like which plugins should be enabled, and yeah, please create an issue for that. That one, not sure if we can maybe decide like where this should, if CSMOG should decide what to run, or maybe like on Packit side we can maybe check or get it from GitHub. Like, yeah, maybe we can take a look at what's changed. So maybe it doesn't make sense to like always run all, or we can maybe like try to get from the projects what type of files is there and maybe run the specific one. Yeah, definitely makes sense. Currently not possible, but doable. There is a possibility to like also like tweak this, like for example like maybe put some flags already, but nothing like automagic for now.
Yeah, interesting talk. I think just kind of following on from the same thing, like all of this seems to be predicated on the assumption that, you know, the change upstream or the change in the package is what is interesting and most likely to cause a failure. You know, so, you know, you have a package, there's a change to the package, or you have a or, you know, it changes in Fedora, or it changes in CentOS or whatever stream. Yeah. Whereas in my experience, like that's one source of where changes come from, but you know, the bigger source, the most problematic one, the one that really hurts, is when there's a new compiler, when there's a mass rebuild, when there's a new glibc, you know, which, yeah, you know, you're touching on a little bit by, you know, running against Fedora, but like, where I guess maybe this is something that your OBS talk talks about a little bit too, because there's more rebuilds there and, you know, more life with Tumbleweed. But like how much of that is it? How much are you tracking changes to your build environment and therefore flagging, you know, this change to the build environment has broken all of these packages?
Yeah. Yeah, definitely this is just a part of like bigger picture, and we would like to see like maybe on a distribution side. That's why not only this upstream check is enough. So, but Bishik wants to probably.
Actually, if you look at the output, it's static analysis. So it's like analyzing the sources, and it's mostly independent of the environment. I mean, like, for a given compiler version, you get
given compiler version, but compiler versions change. And when a compiler version
yes, but if you take the same source RPM and you build it twice, different source RPMs, and you build it twice in the same environment, then you shouldn't see reports about issues that are actually related to the change in the environment. You should see changes related to the source code.
So there are actually.
I was just looking at the list, and it's obvious that those are not things that matter, that depend on the environment.
They actually matter when the compiler changes the defaults for semantics of that language. This is what happened with GCC 15, where they changed the semantics applied by default. And if you are not sticking to older C standards, you get differently treated in certain areas, which means that your code, which was, for example, working.
Yeah, so some code became invalid. They wouldn't compile, but
the code might become not invalid, but undefined behavior might be open at that point. And these analyses might show you something new, and that's good, but it wouldn't be triggered by just using the static analysis in itself. So you wouldn't see this difference between the previous and new run unless you really change the environment between them.
There are maybe like a couple of things we can improve on that side. One is like that C2 tries to run like mass scans regularly, so we can maybe like compare that like on a like bigger scope of packages and compare that regularly, not based on a like upstream change, but like regular.
In Fedora, we do have cache for doing that. So using cache and adding a task to cache to run OpenScanHub through the cache would be a solution.
With Packit, we are looking at cache also for other reasons, but yes, still probably some time ahead, but we'll see. But if you know there are plenty of people that are interested in this, that's like increase the motivation for us to look into that.
So I have a question. Oh, okay, so sorry, go ahead.
Just add to one more point, like, so I did the last mass scan on Fedora in November, and then I used GCC 15 for that. I didn't use GCC 14. I was in discussion with David Malcolm. So we are already in talks with the tools team about how to work better with the mass scans and everything. But that's what I did only with GCC, not with any other analyzer. But you are right, like about the semantics.
Yeah, and at that point, if I remember, we had too many false positives reported.
So we are still working on it. We have some ideas, but you will see some updates in next few months.
Sorry to jump into there, but isn't it just that you would update your static checker for GCC 15 compatibility and then run a mass rebuild on the whole package system to catch those issues in advance? So basically, anytime you make a modification or enhance a new, introduce a big new feature to your static analysis, then it is time to do a bulk run.
Yeah.
So
Go ahead.
I was looking at the output for systemd 257 RC2, and the output, I mean, it seems to be all false positives, more or less. But to analyze them, I need to go to the source code. And I see a snippet and a line number, but actually I would have to always, figure out how to open the file externally and so on and so on.
You just want a better UI on the
like in Cavarity, right? I click and then it pops up a new screen, and then I click again and I go through 5 layers and I see, oh, okay.
Yeah, I mean, I agree with that. It should be expandable, like you should be able to.
Yeah, we are actually looking at that, and also with this serif format to like provide a nice view. Somehow it's also possible on GitHub side to like visualize it. Ideally, we would like to put it like where it belongs, like as a review, so on a specific line of the code. It's not so easy to map like the state of the code when it builds / checks to the original code. So it's not so simple because it doesn't match, but we would like to take a look at that because that would be really, really like where it should go. Okay, so thanks a lot for all the inputs.